A KQED HD production.
This is the last place I ever suspected I would be 4 years ago. I graduated from high school. I played football and lacrosse. I acted and directed plays. I was on student government, and I graduated with a 4.0.
A bright kid with his future opening in front of him. For Austin Whitney, July 21st, 2007 would be the day his life changed forever.
It was just a normal everyday night. I was hanging out with my friends, playing some pool, drinking some beers, but that's about 3:30 in the morning, and I'm in the last quarter mile away from my own house when I went too fast around a turn. My rear side wheel hit the curb, causing my car to flip and wrap itself around a tree. Instantly severing my spinal cord, and paralyzing me from the waist down.
Tragically, Austin's case is hardly unique. Every year, approximately 11,000 people in the U.S. become paralyzed due to spinal cord injuries. Most must face a future where they will never walk again.
So I could either choose to move forward with a negative attitude, which I saw ultimately being self-destructive, or I could choose to move forward and not let that accident compromise my goals, my dreams, my aspirations.
Austin enrolled at the University of California, Berkeley, where his determination ultimately led him to a busy lab tucked away on the edge of campus. There, he found a group of engineers working on a project he hoped might help him move forward.
I heard from a friend that there was this professor who was doing some interesting research. So I came on over, and it's like stepping onto a set of a sci-fi film. It felt pretty surreal, and I got really dreamish when he told me that he had this vision that he would have me walk again. And this is something that anyone in a wheelchair would literally do anything to be able to do again, to be able to walk again.
Professor Homayun Kazaruni heads the Robotics and Human Engineering Lab at UC Berkeley. His team is studying robotics, artificial locomotion, and the development of exoskeletons.
The mission of the lab is about design of robotic devices. We call them exoskeleton systems that are worn by people. You combine human intellect with machine strength. Considering that, you see several applications. You can use these devices for people with mobility disorder in terms of orthotics and prosthetics. So that application made me very excited.
Exoskeletons have long been a staple of science fiction. The idea of a mechanical suit that turns the wearer into a superhero like Iron Man. But for paraplegics, just the chance to walk again would be a superpower.
All the exoskeletons we have built are quite different from the machines that you see in science fiction movies or books. We don't have a device you completely wear it. We need a machine that allows paraplegics to walk. If that's the case, I need two structures. That's all I need, two thin structures on the side, low cost, walk forward.
In 5, 4.
In 2010, less than a year before he would graduate college, Austin began working with Kazaruni and his engineering team as a kind of exoskeleton test pilot with the mutual goal of getting him up and walking.
So here we have one of our Austin exoskeletons, and it's basically an orthotic suit for a paraplegic user. In the back we see two main drive motors which provide power to the legs, and there's a brain of the system, which is all the electronics on the back that controls position and interprets user intent. In a human, your feedback loop starts with your brain decides to make a motion in your legs, and you send commands to your muscles. This is a similar process here, where we have a brain for the system that commands motion.
And that's how you take a step.
The user needs something like a walker, a set of crutches to assist in balancing the system, but that's also their means for controlling the system. So the user, kind of controlling it like a video game, can tell the Exo either to take a step or to sit down or to stand up and so forth. If it looks like he's naturally walking, even with the walker, to the extent that he looks like, an older man walking with a walker, they have to take a step back and remember that he's actually paralyzed.
As the technology takes its first steps, the biggest challenges may move from technological to economic.
Cost is important. A $100,000 walking machine is just not acceptable here. That's too expensive here. Why not $5,000? My prediction is within 10 years, we will have very low-cost, light, high-performance exoskeleton systems for people with mobility disorder, which replaces wheelchairs in many, many areas. In particular, paraplegics, stroke patients, muscular dystrophies.
That's how you walk with the Exo.
Exoskeleton technology has already been put to use helping people walk in a different way.
Now push up, push.
When someone suffers a stroke, it can damage the neural pathways in the brain responsible for executing motor movements. That makes it difficult, if not impossible, to stand up and walk. This exoskeleton made by Tibion in Sunnyvale, California, can detect slight shifts in weight, which triggers the robotic leg to support the patient and to bend, extend, or swing forward. Over time, the movement may help stroke victims' brains rewire themselves so they're able to walk on their own again.
Doesn't that look amazing?
Back in Berkeley, another company, Exobionics, has branched off Dr. Kazaruni's lab and has designed wearable robotics to improve strength and mobility for able-bodied troops on the battlefield. The Hulk exoskeleton, now being developed by Lockheed Martin, can carry heavy combat loads up to 200 pounds over miles of rough terrain.
Today, an American soldier carries about 100 pounds on the back, and they want them even to carry more. Hulk stands for Human Universal Load Carrier, and it's designed to help soldiers so that they don't sustain chronic injuries, which they do a lot today, but also so that they are not completely tired when they arrive. You can crawl, you can bend, you can walk as well as run. So it's basically almost like a ghost that follows you and gives you that augmented strength.
Exobionics is now taking the technology they designed to withstand the rigors of combat and applying it to civilian life.
We find ourselves now at a very exciting time
I'm almost dancing.
because we are about to launch a brand new exoskeleton to the market. And this exoskeleton will allow people that are paralyzed to stand up and walk.
When Tamara Mena was 19, she was in a car accident and was left paralyzed from the chest down.
I think I look so tall, but to you guys, you're probably like, oh, she's pretty short.
She's now working at Exobionics as a test pilot.
I get really excited right before I'm gonna strap in. And then once I'm up, just seeing the world from a standing and upright position, it's indescribable. This experience of getting to walk again, although I might not be walking on my own, it's taught me that hope can be real. It's not just the word that we loosely throw out, which I thought it was, and I kind of gave up on hope. But now I see that it's real, and I think it's giving a lot of people hope.
For Austin and the team at the Kaz Lab, the ultimate goal was having him walk across the stage at his graduation. And right then, a new journey began, both for him personally and also for the technology that helped him achieve his dream.
doctors told me I would never walk again, but here I am walking across the stage. It really makes me hesitant to ever use the word impossible again, ever again.